All right, let's try this bad boy here. So we've got y is greater than x squared minus 9. Now to find my vertex, I got to use negative b over 2a when it's not in vertex form. Now I don't have a b, so what do I use? Well, it's going to be x equals 0 over 2 times 1, so 0 over 2. Oh, I can't have 0. Yes, you can. In the numerator, you can. So it's going to equal 0. So my vertex is at 0, comma. Well, when I plug 0 back in, it's negative 9. So there's my vertex, 0, negative 9, right down here. Lovely. Now let's get some x-intercepts. There's a couple ways of going about this, but essentially we want to set it equal to 0 and figure it out. Figure out where x equals 0. I could factor this. I could use square roots. I'm going to use square roots because I'm crazy like that. So I add 9, I get x squared. I square root, and I get x equals plus or minus 3, meaning my x-intercepts are at 3, 0 and negative 3, 0. Those are my x-intercepts right there. So 3, 0 and negative 3, 0. Awesome. Super awesome. Now I need another point here. And we can use a t-chart. We can go over 1 to the right. Right? We can go 1 to the right. Plug that in. So we plug in a positive 1. That's going to give me a negative 8. So I know my point is right here. And then I can reflect it over my axis of symmetry. Why don't we draw that bad boy in? Okay. And then I can go ahead and graph it. But wait! I need to know what kind of line to do. Solid or dashed. This time, it's just greater than, not equal to. So I need to use a dashed line. When it's equal to, it's a solid line. When it's not equal to, it's a dashed line. Now let's figure out where to shade. So I'm going to use a test point. Why don't I once again use 0, 0? Because it's not on the graph. It usually won't be. It can be. And in which case, you just pick something else somewhere in here that's not on the graph. But 0, 0 is not. So I'm going to use it because it's easy. I get 0 is greater than negative 9. Is that true? I would think so. That means that I'm shading where the 0, 0 is, which is inside the parabola, if you will. And there we go. That was awesome. That was so much fun. Man, I love math.